is structural engineer in SJE Consulting, Australia, and editorial board, Journal of Advanced Civil and Environmental Engineering. He is also a lecturer in civil engineering at the University of Waikato or UOW in New Zealand, visiting researcher at Center for Future Materials or CFM at Toowoomba, Australia, and a former assistant professor 1 at the University of the Philippines, Los Baños.
He was a postdoctoral research fellow for the Center for Future Materials in Toowoomba, Australia. He took Doctor of Philosophy for Civil Engineering at the University of Southern Queensland, Australia, and he also took Master of Engineering at the University of Tokyo, Japan. He is also a member of the Concrete Institute of Australia and the Australasian Association for Engineering Education. Let us all welcome Engineer Ginghis Maranan.
Okay, good morning, good afternoon, everyone. Yep, so I'll just full screen my presentation. Okay, so I'm going to start. So again, good afternoon, everyone. So the title of my presentation is about structural engineering, an overview. So why did I name my presentation as this? Because I think like structural engineering is a broad aspect. So feeling ko the way for me to introduce to you the structural engineering is to give you or to share to you my knowledge and experiences based on my current and previous jobs. Okay, so the summary of my presentation will include a background about myself and a short description about what is structural engineering, what are the roles of structural engineer, roles of structural researcher, and of course, I will give some tips and advice at the end of my presentation. So for a brief background, actually the host already mentioned about my educational history, and these are my previous jobs. So I was actually a structural researcher. Actually, those positions as a visiting researcher and a postdoctoral researcher, I consider that it as a structural researcher because I do study different types of structures, doing analyzing their behavior and performance, and that's why I use the term structural researcher. And also currently I'm a structural engineer. So what is structural engineering? So gawin muna nating general, okay? It deals with the planning, research, analysis, and design of structural components and systems. So what basically are the structural components? These are actually the structural members, such as columns, slab, beams, foundation, and RC wall, which comprise of the reinforced concrete system or frame. So a system could also be a truss, which is made up of top cord, bottom cord, and webs. And the other system is cable systems. Okay. So to give you actually an overview, I was like thinking, how will I be able to share to you or to tell you or to give you information about structural engineering? And the best way is for me to share to you my experiences. Okay, so to start with, I will describe to you or I will share to you what are the roles of structural engineers. So basically, in my job, what I do is I do structural analysis and design of different structures, structural integrity assessment, conduct site project inspection, provide structural solutions, report preparation, and liaise with stakeholders. So yeah, again, I will share to you my the activities that I usually do as a structural engineer. So again, I do structural analysis and design. So of different types of structure. So what type of structure do we usually design? So as you can see here, we design a structure industrial building like this aircraft hangar. So we design this portal frame roof purlins. Okay. So we also design let's say a commercial building like this. It's a multi-purpose sports ground facility. So as you can see here, the projects or buildings I'm showing you are mostly constructed here in Australia because dito ako nag-work. So yung gusto kong i-share, ang mga pictures na makikita nyo dito, basically are usually the projects that I have done here in Australia. Okay? And then here, I have also designed a church. And typically, to design these commercial industrial buildings, we use this portal frame system wherein we design the rafters, the purlins. So you can see here, actually, this is it's like the pre-body diagram. So you can see here, we normally design the column, the footing, the rafters, the roof bracing, and if the truss is needed, so we also design that one as well. So later on, I'll explain to you this structure kung ano yung ginawa ko dito. Okay? So we also design structural and residential houses dito sa Australia. So basically, dito sa Australia, sa atin, for example, sa Pilipinas, it's mostly we use reinforced concrete, okay, as to construct a building. Here sa Australia, mas common yung paggamit ng timber framing system, just as what you can see in the figure. Okay? So basically, yung system nila is they have this timber framing and they use this veneer bricks as cladding. So ito yung example ng bahay na nagawa. And on top of that, actually this house is sitting on top of slab. So dito sa Australia, there are different types of slabs that is usually adapted sa construction. We have a wrap slab and a waffle slab. So the main difference between the wrap slab and waffle slab is that kung makikita niyo yung waffle slab, it is sitting on top of the ground. And as you can see here, to form those voids, they use this polystyrene or styrofoam. Unlike dito sa wrap slab naman, they do excavation and then after that, they lay the reinforcement. Okay? So sa houses, usually we design the rafters, the lintels, the wall bracing, the floor joist, the barriers, stumps, and of course the pier footing support. So we also design bridges here. So basically, yung bridge na na-design ko is uses this system, steel beam concrete deck bridge. So we have this concrete deck. So I designed this as usually a one-way slab concrete. And then after that, i-design ko din yung kanyang mga mga supporting beams, structural steel beams. So usually ito ay made up of universal beams like this one, okay? And then we also design the crosshead and then the column support. So how do we usually, for example ako, how do I usually design a bridge? So usually ang gagawin ko is padadaanan ko siya ng gantong type of track. We call it SM1600. So I have prepared here I'm not sure if you can see the video. How do I share the video? Anyway, so kung makita niyo dito, ito yung mga gulong ng truck. So padadaanan ko yung concrete deck ng ganitong type of truck. And then saka ko i-determine yung maximum shear forces, maximum bending moment. Okay? And then from there, i-design ko na yung reinforced concrete deck and then yung structural steel beam. So dito sa Australia, I was also asked, or in Albury, I was also asked to design a pedestrian cross bridge which will be constructed under this existing road bridge. Kasi ayaw nila yung tao dumadaan dito sa gilid ng bridge. So ang gusto nila is mag-construct ng cross bridge which is made up of trusses. Okay? So it's a bit challenging pero interesting for me. So another structure that I designed are footbridge. Okay. Also, I designed the enforced concrete tanks, solar shade structures. So I designed the rafters, the columns, and the footing. So usually this is very critical in terms of wind load. So, and then hopper trolley support. So this is the hopper. And then I was asked to design this trolley support such that kapag pinagalaw siya, hindi siya matutumba. So I also designed public amenities and restrooms. Okay? And then mga foundation or footing support for signages. So kung ma-realize nyo, iba-iba yung, ang dami ko pa bang actually iba't ibang types of structure or projects na ginagawa. So sobrang varied yung ginagawa ko. So yun yung sa company namin, it's a small company, pero kami mga structural engineer kami exposed into different types of projects. Unlike if you work in a big company, nag-specialize ka lang sa isang area. Let's say, magdi-design ka lang ng high-rise building or ng bridge lang. Pero, malaki yung project na yon. Kami naman, mga maliliit na project, pero iba't iba naman yung ginagawa namin. Okay? So, aside from doing structural analysis and design, I also do structural integrity assessment. So, one good example that I can share to you is this, itong second floor, analysis nitong second floor nitong isang building, itong World's Gym, which is located Hills or Albury. Kung makikita nyo, ito yung flooring ng second floor. Medyo hindi nila talaga ginagamit. So, ang plan nila is to expand their gym by using this floor. Okay? So, basically, gusto nilang malaman gaano kabigat, anong weight ang kayang i-carry ng building na to, ng floor na ito. So, to do that, okay, so ang gagawin ko usually is, again, to determine kung ano yung type of wood ang meron, itong timber deck na to, ano yung kanyang dimension. Aside from that, I will also determine kung ano yung mga floor, ano naman yung floor joists na nagsusupport sa mga timber deck na yon. So, I need to determine kung ano yung kanyang spacing, ano yung haba nitong mga timber joist, and then what else? Kung anong type of wood ba siya, kung hardwood ba siya, softwood, or made up of laminated veneer timber. So, after determining that, syempre, i-determine ko naman next is yung mga bearers. So, here, they uses steel floor bearer. So here, gumamit sila ng sobrang lumang structure. I think itong building na to was built in 1930. So kung makita nyo, itong section na to, kung baga tayo, based sa inyo yung experience, I guess sa ES30, merong specific table na for specific section. Ito, wala akong makitang span tables or table na makita ko yung properties ko. So, medyo challenging siya kasi kailangan kong gumamit ng long formula just to determine the bending moment capacity, the shear capacity, and the compression capacity of this section. Okay, so this is the bearer. And then after that, syempre pag na-determine ko na yung capacity ng bearer, next is yung kanyang column or post, which after that, i-determine ko din yung capacity ng pedestal kung saan patong yung column natin. Okay? I also, of course, I also check the connection details. Kung sapat ba na i-carry ng load or anong load, what weight ang kayang i-carry nitong connection na to. Okay? So, yun yung isa. Another project na kung saan ginamitan ko ng assessment is this industrial building. Gusto nilang magtayo ng isang mezzanine floor. Ngayon, wala silang idea kung anong gagawin nila, anong magiging spacing halimbawa ng column, anong size ng floor joist, anong size ng bearer. So, ang naging suggestion ko is first, since itong column na to will sit on top of a slab on ground, so ang suggestion ko is to determine the punching shear capacity of this slab, and then also the bearing capacity of the soil. from there, I was able to determine kung ano yung load na pwedeng mag-access slab. Since alam ko na yung dead load at live load, based on the punching shear capacity nitong slab na to ng ground, saka ako dinesign yung mga sections ko, yung sizes ng mga members ko. So usually here, gumamit sila ng, actually here, na-design ko na yung mga floor joists nila, which is they usually use a C-section. Okay? And then yung bearer, ginamitan ko ng PFC, parallel flange section, and a square hollow sections, which has a base plate at the bottom para ma-distribute yung force doon sa slab. Okay? So another assessment job is kasi dito sa Australia, before you can construct something, you need to have an engineer to assess whether yung structure is kaya niyang mag-carry ng mga loads. For example, itong carport na to, it is made up of truss with RHS, rectangular hollow sections, and then may mga webbings. Ganun din sa top chord, rectangular hollow section siya. So, ang sabi ng council dito or ng local government dito, ipa-assess ito kasi otherwise tatanggalin siya kapag walang engineer na nag-assess ng capacity nito. And then actually, based sa analysis ko, nung nag-conduct na ako ng analysis, itong carport nila is actually adequate lang to carry dead load only. So pag may taong aakyat sa taas, kailangan ng mga temporary propping dyan. That is because yung kanilang ginamit na stub column here dito sa roof ay sobrang liit ng size. Circular hollow steel tube yung ginamit nila, pero that circular hollow steel tube is not enough to support a live load. So, dito ang recommendation ko, walang taong aakyat dito. Pag may aakyat, kailangan merong temporary support. Okay? So, yan. Ito yung maliit na circular hollow tube section. Okay? Sitting on top of the wall, brick wall. So, another assessment job is this. Kasi gusto ng owner gumamit nitong gamitin tong lumang king post truss. Okay? So, gusto nila malaman ano yung load rating o load bearing capacity nito. The thing is, I need to do a research kung ano yung anong type of wood to kasi sobrang luma na kung makita nyo. Siguro more than 50 years na tong king post truss na to. Pero mahilig kasi sila sa mga medyo old style structure kaya gusto nilang gamitin. So there are 5 pieces here, but then again, nagkaroon ako ng recommendation kung gaano kabigat ang pwedeng i-carry ng truss na to. Okay? Yan. So aside from structural integrity assessment, we also conduct site or project inspection. Okay? So one good example that I'll share to you is itong 6-story residential retail building dito sa Albury. Ito yung the Hamilton building. So basically, dito nagawa na yung design. Kami, ang gusto ng owner is for us to check whether the design is being followed. So ang gusto nila i-check yung, let's say ito, they want to check kung yung spacing ng rebars ay nasunod ba, yung rebars ay tama. Okay, so including this footing. And then this is slab, kung nagamit ba ay SL82. SL82 meaning mesh. Okay, I'm not sure if it's common in the Philippines, pero ibig sabihin, yung SLA nito, mesh siya na, ready-made na mesh na siya. Kumbaga, hindi mo na kailangan pagpatong-patungin. So, SL82 meaning 7.5 yung diameter, 200 mm yung spacing. So, I also checked the columns kung nasunod ba yung required spacing ng stirrups. This one, I'm very particular with the spacing, of course, ng stirrups. Papalapit sa may joint, okay? The more na papalapit ka dun sa joint or dun sa support, let's say sa beam column joint connection, kailangan mas masinsin ng stirrup kasi yung shear load doon, mas mataas. Pero as you go in the middle, mas nagiging maluwang yung spacing. And of course, I also check yung mga bakal, yung mga sizes ng bakal, dapat nasunod yung na-specify na diameter sa design. So I also, this one is a blade column, okay? Parang, ito yung wall na ginawa siyang column. Okay? So makita niyo yung spacing ng kanyang shear reinforcement, masinsin sa may papapunta sa may slab or beam, and then papunta sa gitna, makita niyo yung spacing mas maluluwag. Okay? So, ito naman, yung slab niya actually is made up of pre-stressed concrete slab. So, I also check the reinforcement of that. Including yung concrete ramp reinforcement. Okay? Aside from that, we also check itong shoring and itong mga formworks and temporary shoring. So, makikita nyo dito, itong portion na to, yan, ipinapa-adjust namin yan. Kasi ayaw natin ng eccentric loading. So, gusto natin, kagaya nito, na yung mga support is nasa gitna. So, one good example, ito, tulad nito, kailangan itong timber na to, kailangan i-adjust natin such that it will be aligned to this shoring. Okay? So, yun, minomonitor din namin yan, pati spacing ng mga temporary shoring na to. So, another project na ginagawa namin or ini-inspect is this chemical dosage tank. So, usually, ito ay ginagamit to store water and other chemicals. So basically, itong chemical dosage tank na to, it is made up of different concrete panels. So makikita mo dito, nakalay na yung mga reinforcement and then may opening. Yan basically yung nagiging, halimbawa, door. Okay? So ito yung sa walls, let's say ito yung sa other side of wall, ito yung entrance ng pinto. So pag binuo mo yan na parang Lego, magkakaroon ka ng chemical dosage tank. So usually, ang gusto ng owner is for us again to check if the design is being followed. So yan, minomonitor namin yung concrete placement nila, kung binabibrate ba, kung properly laid yung mga reinforcement, and then yung pag-level nila, okay, yung leveling procedure nila, and then yung kanilang yung pagbabibrate ng concrete. So we also monitor kung yung mechanical yung properties ng concrete. We want to make sure na meron siyang adequate slump. As reported here, kailangan 120. Last time nung nagkaroon kami ng site inspection, ang slump lang is around 50. So hindi namin pinayagan, okay? Kasi this is a chemical dosage tank. So kailangan talaga yung mga concrete is makakapasok sa mga singit-singit. Again, yung slump, it defines the workability ng concrete. Ngayon, pag mababa yung slump, ibig sabihin hindi flowable, masyadong viscous yung concrete. Hindi siya papasok sa mga singit-singit or mga corner. So kailangan yung mataas yung workability niya. So pinaulit namin, okay? And then we also monitor the temperature, and also syempre at the end of the day kailangan namin malaman yung concrete strength na ginamit nila. Okay? Ito another typical project na ginagawa namin to inspect again the reinforcement. Ito ay slab on ground. Actually, this is a wrap slab, okay? Na we also monitor yung kanyang reinforcement. And for example, here we want to make sure na itong mga services, meron kang mga bakal na naka-support doon sa opening. Itong mga diagonal bars dito. Okay? Kasi parang kinat mo yung bakal dyan, so to compensate yung mga bakal na nawala, so you provide this additional bars. So we also check ito nga, another project, commercial building sa North Bandiana. So tulad nito, dito sa isang malaking slab on ground, usually kailangan meron kang saw-cut joint. Kung makita mo yung mga bakal dito, may putol yan, may putol doon, may putol dito. So, para saan ang saw-cut joint? Usually, para yan sa kapag merong to prevent yung mga cracks sa concrete kapag nagkakaroon ng shrinkage. So, di ba, usually ang concrete, pag nag-cure siya, o through time, nag-evaporate yung water. So, mag-shrink siya. So, ito, nagkakaroon tayo ng cut para mabawasan yung stress na para kumbaga meron na siyang automatic na cut. So, yung cracking within the solid section, ma-prevent natin. The other one is we also check kung meron ba kung tama ba yung dowel joint location. So, anong purpose usually ng dowel joint? Actually, that is to be able to transfer yung vertical loads dito sa isang slab na to to the other slab. And we want to make sure na hindi magkakaroon ng differential settlement between the two slabs. Okay? So, yan yung purpose ng dowel. So, we also check mga footing, yung kung ilang bakal, usually kailangan yung hukay. So, ang goal natin, 900 by 1,300 deep na footing. So, kailangan meron 10 bakal, 10 and 20, and then meron yung ligatures mo, or yung ties, na yung diameter is 12, then yung 500 yung spacing. Okay? So, we also monitor that one. And then the other interesting na ginagawa ng structural engineer ay to provide structural solutions. So ano to yung mga, I'll give you some examples, very interesting projects na nagawa ko na sobrang challenging, but again, as I have said, very interesting kasi I'm really into structural engineering. So for example, itong church na pinakita ko sa inyo last time dito sa Wodonga, Victoria, kung saan ako nakatira. So, ito yung structural framing niya, yung parang body diagram. Ang gusto nila, magkaroon ng opening dito sa portion na to. Okay? Ngayon, we have this one. Walang column dyan na nagsusupport. So, ang problema dito sa member na to is, nagkakaroon siya ng lateral deflection. Okay? So, ano yung naging proposal ko to prevent those itong lateral deflection? Ang naging solution ko is to use this combination of steel sections wherein I have this universal beam, ito yung universal beam, UB, sitting on top of this parallel flange section. So usually, itong parallel flange section, siya magre-resist ng lateral deflection, while itong 250 UB26, siya naman ang magre-resist ng vertical loads, okay, or vertical loading. So basically sa site, sobrang interesting kasi marami kang maiisip or kailangan mag-isip ka kung paano mo gagawin na hindi mo natin ma-encounter usually sa pag nasa school lang tayo sa university. Okay? Now, another interesting project na ginagawa ko is, let's say, itong commercial building na to, gusto nilang tanggalin itong, magkakaroon actually, etong from part na to, hanggang dito is existing na siya. Ngayon, gusto nilang i-extend ng 2 bays. Okay? Pero ayaw nila ng column dyan. Gusto nila mag-run ng truss dyan. Itong kulay orange. Gusto nila mag-run ng truss dyan. So, pag kinat mo dito sa section na to, ito yung makikita mo yung view. So magkakaroon ka ng column dito, rafters dyan, truss dito. Another problem dyan, itong truss na to na 1 meter deep is yung lateral deflection. Okay? So, ito yung kanyang naging free body diagram. Again, you have the column, the rafters, and then the truss. Ang challenging na part dyan is yung lateral deflection. Nung una, ang ginawa ko, idinagdag ko yung, naglagay ako ng bracing from this joint to the bottom of that truss and then from that joint to the bottom of the truss. Nagde-deflect pa rin too much itong portion na to. Kasi, di ba kapag may vertical load ka dito, dyan, babagsak din itong ridge na to, So parang wala siyang pinoprovide na resistance, itong pag dito mo nilagay. Pero, nung inilagay ko dito yung aking bracing dito sa may mid portion dito, and then naglagay ako ng strut dyan, I was able to minimize itong lateral deflection. So, very interesting talaga ang structural engineering. Okay? So, another problem na gusto nating i-solve. For example, may isang lumang, actually it's a heritage building. Ayaw nilang i-demolish or palitan ng bago. So ang gusto nila, gamitin pa rin nila itong mga bearer na to. Itong mga bearer na luma na. Actually parang nasunog na to eh. So ang gusto nila is gamitin pa rin siya. So parang sabi ko, paano kayo ang gagawin ko? So, nag-propose ako na, okay, sige, magagamit pa rin natin siya, pero ang gagawin natin, we will remove yung mga damaged portion and replace it with a new timber. And then, syempre, kung meron tayong bagong ididikit, kailangan natin ng connection details. So, ngayon, nag-propose ako ng gantong connection na, ito, halimbawa, ito yung old undamaged timber section, yung portion na yan, and then you have this new timber section, connected siya with two plates, okay? And then we will connect them using 8 M12 bolts. So, yung analysis na yan, if interested kayo, pwede ko siyang i-share sa inyo later on. So, ito yung proposed rectification ko. Actually, ito yung new timber, and then makita mo, nasa sandwich siya ng 2 plates using 2 bolts. Okay? Yep, so yon. Another challenge, okay, is yung pagdi-design naman ng cantilever slab na 3 meter long. Okay? So, para sa bahay na to. So, initially, ang design ko is may slab na dito sa loob, pero ito yung cantilever span. So, ang goal ko is to extend na lang yung 230 mm concrete thick slab na diretso. Pero ang gusto ni owner, magkaroon ng 80 mm groove for operable doors. Dito dadaan. Gusto nila may operable doors dyan sa portion na to. So, ang mangyayari, yung depth na 230 ko dito, nabawasan na. So, parang kulang. Anong pwede kong gawin? So, ang naisip kong option is, since nagbawas ako ng 80, magdadagdag ako ng 80 dito. Ang problema, lumaki yung section ko dito na dagdagan yung weight ng aking concrete. So, very challenging. Sabi ko, ano kayong gagawin ko dito? So, nag-isip ako, ang naisip kong proposal is to utilize a tapered section. So, again, nakita mo dito, yung required na 230 na-achieve pa rin natin, pero pagdating mo sa end, nire-reduce mo na yung cross-section para mabawasan yung self-weight ng slab. Okay? So, first time ko itong na-encounter kasi usually tayo sa school, pag nag-design, okay, isang cross-section lang. Pero dito, magagamit mo talaga yung creativity mo as a structural engineer. Okay, another problem. Ito dito sa Albury, New South Wales, maraming mga old buildings na ayaw nilang gibain kasi dahil sa mga historical importance nila. Tulad nitong The Globe Hotel dito sa Albury. So, pag pumasok ka sa second floor, makikita mo itong ganito kalumang structure. Actually, alam mo, ang goal nila dito is gamitin yung ground floor as mga shopping areas. Okay? So, may magtatayo sila dyan ng mga shops na sobrang lawak ng mga space ng area. So, ang goal nila, okay, is to renovate that. Alam nyo ang challenging part dyan? Kasi yung pinakababa, yung ground, is made up of brick wall. Siya yung actually ginagamit na pang support usually nitong second floor. So makikita nyo itong mga brick wall na to, continue yan sa baba. Okay? Ito yung second floor nyo, dire-diretso yan sa baba. And so, ang gusto nila, tanggalin itong mga brick wall na to, itong mga wall na to, para magkaroon ng malawak na space para sa shop. And then yung structural layout niya medyo challenging, medyo kakaiba. So, anong ginawa ko? For example, dito, gusto nilang tanggalin itong wall na to. Ito. For example, itong wall na to, gusto nilang tanggalin, Pero pagkatanggal nila, makikita mo may mga itong steel beam na to actually ay ito yan. Itong portion na to. And then itong beam na to ay sitting on top of that slab. So, ang ginawa kong proposal, actually, para matanggal lang tong wall na to, is to add a supporting beam with a column there. Okay? So, ito medyo challenging kasi kailangan mag-imagine ka anong load ang i-carry niya, gaano kabigat, kasi wala na siyang plano. Ito ang pinaka-challenging part na to. Wala siyang detailed plan previously. So, kailangan magaling ka, yung assumptions mo, yung yung weight ng mga na i-carry niya, kailangan magkaroon ka ng idea. So doon talaga papasok yung kailangan may experience ka. So for example, tulad nito naglagay na sila ng column diyan, and then eto na yung final ito, actually, kaka-picture ka lang nito last week. So makita nyo, sobrang natanggal na yung wall dito, pati yung mga wall dyan. So meron na silang malawak na space for retail shop. So itong column na to, maraming nakadikit na beams dyan na old structure. So kailangan mo pa rin i-analyze yung mga yun. And then imaginein mo kung ano yung nasa taas niyan. Sobrang complicated. So very challenging, pero gusto ko siya kasi na-enjoy ko talaga itong pagdi-design ng mga structure. Ito, yung sabi ko sa inyo is, for example, itong wall na to, ito, dire-diretso from ground to floor. So, gusto nilang tanggalin tong portion na to. So, may maiiwan na brick wall dyan na napakabigat. So, ano yung naging proposition ko? So, tanggalin yung brick wall sa ground and then maglagay ng parallel plunge sections, okay, tulad nito, then maglagay ng bolts. Parang isa-sandwich natin yung remaining. Tapos meron kang 10mm plate. So parang ito yung nangyari. Ito yung 10mm plate mo, ito yung parallel plunge sections mo. So itong nakikita nyo dito, yung mga vertical na yan, mga stiffeners yan para hindi mag-bend yung iyong plunges ng beam mo. Okay? So ito, tulad nito, di ba ito yung kanina, nandyan yung wall, ito na siya ngayon. Wala na yung wall, pero nakita nyo yung parallel plunge section and then yung 10 steel plates. So, inadapt yan sa lahat halos ng portion kung saan tinanggal nila yung brick walls. Okay? So, yep. So, after providing structural solutions, siyempre, magpe-prepare tayo ng report. So, usually, ano yung mga report, ano yung content ng report na ginagawa namin? Usually, kailangan i-report namin na, yes, nasunod ba yung design? So, ni-mention namin na, okay, yung excavation, tama, 900mm yung diameter, yung total depth is 1,300, and reinforced with 10 and 20 and 12,500 ligatures. So, column foundations. So, yan, example yan ng report namin for column foundations. For example, doon naman sa floor, doon sa World's Gym floor na inassess namin, nag-end up, ang load rating niya, based sa analysis ko, is 3 kilopascal. Ito yun lang yung kaya niyang i-carry kasi nga, due to the deflection limitation of the timber floor joist. So ito yung mga example ng report na piniprepare ko after ko mag-conduct ng inspection o magkaroon ng structural integrity assessment. So, the last activity na ginagawa ko generally is makipag-communicate sa mga clients, sa architects, at sa mga engineers. So, ito yung group namin. Okay? So, we want to make sure, for example ako, last Friday, nakipag-meeting ako sa mga client, I want to make sure na yung kanyang design requirements o yung preferred niya is masusunod. And then after that, syempre, pagkatapos kong mag-design, I want to make sure na yung drafters o yung taga-drawing, maintindihan ko ano yung gusto kong, ano yung dinesign ko. So usually, ang gagawin ko, merong architectural plan dyan, tapos saka ko lalagyan ng mga markups kung saan ko gustong ilagay yung poste, ano yung spacing ng mga columns, tapos kung saan ang bracing. So, ganyan. And then, pag usually, ganito yung setup or yung document na binibigay ko sa architect. Nandyan yung mga members, okay, kung saan located. And then, makita nyo sa right side, yung definition. Let's say, yung itong R1, that is rafter R1. Ang naka-define dito, 260 UB 31 plus ply brace every second purlin. Tapos, gano'n siya kahaba. So, ganito usually yung typical drawings na, or typical document na binibigay ko sa architect. Kasi take note, tayo as structural engineer, yes, pagkatapos natin mag-calculate lahat, okay, done. The question is, pagdating sa site, ang titingnan nila is yung drawings, not kung paano tayo nag-calculate. So, it is very important na you are able to effectively transfer kung ano yung dinesign mo doon sa drawings. Kaya kailangan yung mga drafters maiintindihan. So, para mas maintindihan pa ng drafters yung gusto kong mangyari sa design, nagbibigay ako sa kanila ng mga sketches, ng mga connection details, halimbawa ito ng column, tas ng rafter, ano yung kailangan plates between them, kung ilang bolts, kung anong weld ang gagamitin, and then let's say itong connection ng rafters, okay? So kailangan natin mag-provide din ng sketch to them. And then tulad nito, halimbawa, napaka-critical nitong layout nitong rebar. So ako yung nag-suggest na ganito dapat ang layout ng mga bakal, okay? Just to make sure na itong slab na to will be able to carry the imposed dead loads and live loads. Okay? So yan yung trabaho ko as a structural engineer. Mainly yung 6 na yon. Now next is, I also want to share to you yung job ko as a structural researcher. Okay? So basically, I will explain to you my job as structural researcher by explaining to you itong bagong technology na tinatawag ko na glass fiber reinforced polymer reinforced geopolymer concrete. So, ano ito? Actually, para siyang reinforced concrete. Okay? Yung konkreto, pinalitan lang natin ng geopolymer. Yung mga steel bar, pinalitan lang natin ng mga glass fibers, reinforced polymer. Ito yung mga plastics or polymer reinforced with glass fibers. So, as a structural researcher, actually, nag-iisip ako ano kaya magandang topic, okay? So ang structural researcher, parang sila yung mga may ginagawa bago i-apply in real world, okay? Nire-research natin yung structural properties ng mga bagong material. So ito, nag-iisip ako, okay, reinforced concrete, ginagamit na siya. Anong problema niya, okay? Anong problema sa kanya? So naisip ko, ang problema sa reinforced concrete is that nagko-corrode yung reinforcement, and then yung semento is not sustainable, plus of course yung weight ng mga bakal is mabigat. Okay? So to address those problems, actually ang ginagamit ngayon is either to use GFRP rebars para ma-address yung corrosion, o kaya to address naman yung sustainability problem ng concrete, gumagamit ng geopolymer. At nag-research ako, based on my research, wala pang nagagawang research about the combined use of these two materials, nitong GFRP at saka ng geopolymer concrete. So ang naging goal ko is to check whether itong geopolymer concrete reinforced with GFRP rebars is possible to be used for construction. Yan yung naging work ko mainly as a structural researcher. So again, nag-research ako about properties ng geopolymer concrete. It has high sustainability and high durability. So basically, itong geopolymer concrete, it is made up of fly ash and slugs. Tapos yung pang-binder mo is sodium hydroxide. Okay? So actually, itong fly ash and slugs, there are byproduct materials. So, waste materials. And then, ito namang GFRP rebars, they are corrosion resistant. So, usually, they are made up of vinyl ester, okay, reinforced with glass fibers. They have high tensile strength. So, yon. Ito yung typical properties ng GFRP rebars na ginamit ko. Yung tensile strength, kung mapapansin nyo, it's 2 times higher than the yield strength of rebar, which is 500 megapascal. Pero ang disadvantage ng rebar na to is yung kanyang modulus of elasticity. Masyadong mababa. Okay? So 50 or 60 gigapascal versus 200 megapascal. Meaning, ang challenge dito sa paggamit ng rebar is nagde-deflect siya too much. Meaning, pag nagde-deflect siya, mas magkakos ng cracking. Yun yung disadvantage. Ito naman geopolymer concrete, yung properties niya is almost similar sa concrete. So, as a structural researcher, kung gusto mong study itong new materials, what you're gonna do, usually, of course, magpe-prepare ka ng lahat ng materials mo, maghahalo ka ng konkreto, and then saka ka magbubuhos. Pati itong formworks na to, ako din yung nag-fabricate. Yan, kung makikita nyo, ako din nag-fabricate nitong reinforcement cages na to. And then after that, ika-characterize nyo yung properties ng bawat material. Aalamin nyo yung compressive strength ng concrete, yung tensile strength ng RP rebar, yung shear strength niya. Kasi gagamitin nyo yan later on para sa pag-determine. Kasi later I'll explain that kung bakit kailangan natin ng properties niya. And then after that, yung na-fabricate nyo na beam, geopolymer concrete beam with GFRP reinforcement at the bottom, i-test na natin siya. So itong beam na to is 3 meter long. Okay? And then of course, may comparison ako dito. Nag-fabricate din ako ng beam reinforced with steel bar para lang ma-compare ko ano yung difference between the two. And then also tested yung compression capacity nitong geopolymer concrete reinforced with GFRP bars. So after natin mag-conduct ng mga structural testing, ipaprocess natin lahat ng results, okay? And then i-analyze natin siya, and then after that, magpapublish na tayo ng mga technical papers, okay? And then also, aside from publishing technical papers, you also present your projects in different conferences. So actually last conference na natinan ko is yung CICE sa Paris, sa Paris, France. Okay, so I presented then yung project ko. And then of course, use this opportunity to network, okay? To increase your mga kakilala mo, yung mga contacts mo. So dito, mas maganda, magkakaroon ka ng mas maraming ka-collaborator. Okay? Ka-collaboration. Yep. So yun yung work ng structural researcher. Okay? And then ito na, sa last part is yung mga tips or advice ko. Yun nga, nabanggit ko na itong pag halimbawa nag-graduate na kayo at mag-start na kayo mag-work, usually, ito yung point of comparison ko. Small company versus a big company. So usually, pag nasa big companies ka, like GHD or ano pa bang mga ibang malaking companies. So usually, pag structural engineer ka, parang specialize ka lang sa isang bagay. Parang kang nag-PhD. Pero kapag sa small company ka, parang kang undergrad. Expose ka into different projects na small projects lang. Okay? And then yung mga design codes, siyempre nagturo ako dito sa atin sa Pilipinas, nagturo ako sa Australia, and then nagturo ako sa New Zealand. So nakita ko, design philosophy is the same. We use ultimate strength design, working stress design, pero nagbabago-bago lang sa mga parameters. For example, sa National Structural Code, not sure kung ginagamit pa rin yung 0.85 F'(CAB) for concrete to calculate the compressive strength of concrete. Pero dito sa Australia, sa Australian standard, we use alpha 2 F'(C). Tapos meron ka pang formula ng alpha 2. And then ito yung modulus of elasticity ng concrete for a specific strength. So, magkaiba sila, pero again, the procedure is the same. Yung mga formula, yung mga factor of safety lang ang different. And then, ako, for example, in my job, required kaming mag-conduct ng mga first few months namin, first 5 months or 6 months, we do hand calculation. Ang very challenging dyan is yung pagsusulat at the same time pagka-calculate. So nag-isip ako, paano ko kaya mapapabilis ang calculation ko? So nag-isip ako, MathCAD. MathCAD is pwede, parang ganito yung format niya. Kaso may bayad siya. So, ang nangyari, nag-research ako ng mura and then nahanap ko tong SMAT Studio na para siyang spreadsheet, nakasulat yung mga equation mo dyan, pero parang ang performance niya is parang MATCAD. So, yung job na dati kailangan kong tapusin in 1 day or 2 day, natatapos ko lang siya in 3 hours. Dahil nga, meron akong ready-made na spreadsheet na ikinaka-copy-paste ko na lang. So, another software na free para to calculate, let's say, itong compressive strength ng circular columns. Alam nyo to, nag-calculate kayo, yung iba na natapos ng reinforced concrete, masyadong mahaba yung calculation for a circular column. So, at actually, may interaction diagram. Pero dito, meron ng software, okay? So yeah, be resourceful to increase your efficiency or productivity. So ito pang isa. Kasi for example, parang na-realize ko, nung nagtuturo ako ng CE 132, ang dami kong formulang equations, ng deflections, ng ano pa ba, bending moment na pinapamemorize. Pero in real life, ibibigay naman talaga siya. So, for example, ako, pag may nagpapadesign sa akin na napakabilis, gusto niya very quick. So, hindi ko sinasuggest na gamitin, pero I'm just sharing you itong ginagawa ko. So, gagamitin ko lang simply supported beam kasi usually siya yung magde-deflect at mag-undergo ng mas malaking bending moment. Kasi yung deflection niya is, or yung stress, or yung stress experienced by simply supported beam is usually 4 times or 2 times higher than a beam na may fixed support at the end. Okay? So, pero hindi ko nire-recommend to ha. Nag-share lang. Okay? And then, be diplomatic in asserting your design recommendation. Tulad nito, nung nakita ko yung mga bakal, sabi ko, paano papasok yung mga graba dito? Siyempre, medyo ano ka, pero kailangan mong i-control ang sarili mo and then tell them na, halimbawa, for example, tell them anong mangyayari ko pag nagbuhos na tayo ng konkreto tapos hindi makapasok ang bakal, mag-fail yung structure. So, for example, ako as a designer, sabihin ko, ito yung proposal ko pero hindi nyo sununod, sinong sisisihin sa bandang huli, di ba kayo? So, at least, after nung na-explain ko yon, binago na nila yung isa. So, dapat ito nakakrank. Ibig sabihin, itong bakal na to, doon mo i-overlap sa ilalim ng bakal na to. Okay? Hindi side by side. Kasi nawala na ng space. Okay? And then, of course, I will advise to improve your skills by studying design codes, design examples, new softwares, and new technology. And I think that's it for me. Thank you.